So, welcome to today's deep dive. We are getting into something that, well, it honestly challenges a habit that's been baked into our brains for a century.
Oh, absolutely. It's a completely ingrained behavior.
Right, like if you've been driving for any amount of time, when that needle dips toward E, your brain just automatically kicks into a very specific subroutine.
Yeah, you scan the horizon, you find a sign, you pull over.
Exactly. You park next to a pump,
Yeah.
and you bring the car to the fuel. It's basically an immovable law of modern life. The car always goes to the gas station.
I mean, the whole infrastructure is literally rooted in the ground, and the entire burden of finding it, navigating to that energy source, that falls entirely on you, the driver.
But today we are diving into a stack of sources that suggest that century-old habit is about to be completely inverted. We've got some fascinating stuff here.
Yeah, a really great mix of documents this time.
We do. We're pulling from procurement documents from the state of Ohio, featuring this mobile charging company called SparkCharge. We also have a really highly detailed tech and market analysis from Trellis, covering one of their competitors called FreeWire. And to top it all off, some leaked internal testing data from AAA's roadside service division.
Which is super revealing data, by the way.
It really is. And the mission for this deep dive is to map out this massive shift. The electric vehicle industry is basically looking at our slow-moving electrical grid and, well, deciding to bypass it entirely.
They're tired of waiting.
Exactly. Instead of you going to the power is coming to you.
And, the overarching problem driving all of this innovation is permanent infrastructure lag. It's just too slow.
The grid can't keep up with the cars.
Exactly. As EVs just fly off the dealer lots, upgrading a local electrical grid to handle massive high-speed DC fast charging, it takes immense capital. You need utility cooperation and, frankly, years of bureaucratic wrangling.
So these companies are hunting for workarounds.
Right. They are targeting that visceral, very human emotion of range anxiety by basically decoupling the charger from the earth.
Let's start with SparkCharge, because the mechanics of what they're doing initially sound kind of like science fiction.
It does sound a bit wild at first.
To help you visualize it, imagine a portable smartphone power bank, but scaled up so massively that it can run a 2-ton vehicle.
Yeah, that's actually a really solid baseline for the concept. The SparkCharge Roadie Portable is totally untethered.
No extension cords.
Right, you aren't stringing some heavy-duty extension cord across a municipal parking lot.
And looking at the physical specs from that Ohio procurement document, the design is totally modular. They actually describe it literally as Lego blocks of range.
Which is such a great way to picture it.
It is. There's this main charger module that weighs about 20 pounds, 9 kilograms. And beneath that, you stack the battery modules.
And those are pretty hefty.
Yeah. Each battery is nearly 50 pounds, holding 3.5 kilowatt hours of total energy, with about 3.2 of that being usable.
So you stack it up, clip it together.
Exactly. You stack the battery, clip the charger on top, plug in your standard DC fast charge connector, and the power just flows. Whether you have a CHAdeMO or an SAE combo, it works.
And the real breakthrough there isn't just putting lithium-ion cells in a plastic box. I mean, anyone can do that. It's the output management.
It's how fast they get the juice out.
Right. That unit delivers a 20-kilowatt continuous fast charge. They somehow managed to squeeze level 3 DC fast charging speeds out of something you can physically pick up and carry.
Which is wild. Because of that 20-kilowatt output, it pushes power into the car at a rate of 1 mile of range every 60 seconds.
That's incredibly fast for a portable unit.
It's up to 14 times faster than a standard wall outlet. So 10 minutes plugged into the stack, you have 10 miles of range to get to a permanent station.
Which solves the immediate emergency.
It does, but here is my major pushback on the reality of this hardware for an everyday driver.
Okay, let's hear it.
If I'm stranded, sure, absolutely, hand me 10 miles of range. But practically speaking, you are talking about a 20-pound charger and a 50-pound battery.
Yeah, that's 70 pounds of dead weight.
Right. Is anyone realistically going to haul a 70-pound stack of lithium-ion batteries around in the trunk of their car every single day?
Probably not.
Sounds like a fast track to a chiropractor visit. Plus, it just eats into the car's efficiency having to drag that weight around.
No, you're totally right. Nobody wants to play CrossFit with a car battery. And, SparkCharge realized the exact friction point you just mentioned.
They saw the writing on the wall.
Exactly. The everyday consumer is just not the primary market for physically moving these units. The Trellis article details how they pivoted their entire business model to what they call the Roadie V3.
Oh, right, the van.
Right. Instead of selling you a heavy battery to lug around, they shifted to charging as a service. They took this modular Lego block tech, scaled it way up, and built it into an electric van.
So the van itself basically becomes the roving gas station.
Precisely. The van drives around delivering DC fast charging directly to decentralized fleets. Yeah, think about a rideshare driver. They lose money every single minute they are sitting parked at a public charger.
Oh, for sure. Time is money for them.
With this service, the SparkCharge van comes to the driver while they're eating lunch or, taking a break. They literally deliver 20 to 50 miles of range directly to wherever the car is parked.
The scale of that pivot is huge. The Trellis report actually notes that in 2023 alone, SparkCharge powered 1 million vehicle miles this way.
Just driving around, topping people up.
Yeah, just delivering power like a pizza. And going back to the Ohio procurement document, this is where it really clicks into place for municipal governments.
Oh, the EV United campaign?
Yes. SparkCharge launched this partnership called EV United. It's a 2-year campaign targeting state agencies specifically in Ohio.
And if you look at it from the perspective of a state agency fleet manager, it makes perfect sense.
How so?
Well, imagine you have a mandate from the governor to electrify your entire fleet of state sedans. But to install permanent level 3 chargers, you have to tear up a municipal parking lot.
Digging trenches, laying high-voltage conduit.
Exactly. And then you have to wait for the utility company to come out and upgrade your local transformer. That whole process can take 2 or 3 years easily.
That's a massive bottleneck.
But SparkCharge allows them to electrify their fleet instantly. The vans just come to the parking lot at night, charge the cars, and that entire multi-year infrastructure delay is completely bypassed.
That's incredible. But, if SparkCharge represents this pizza delivery model of EV power, bringing it hot and fresh right to your doorstep, why did their major competitor walk away from that exact strategy?
Yeah.
FreeWire.
Right. The Trellis article focuses heavily on FreeWire, and it points out that FreeWire completely abandoned the mobile delivery van model. Why?
It basically comes down to the unforgiving laws of physics. FreeWire actually started out in 2014 doing the exact same thing, trucking mobile charging units from car to car.
Oh, I didn't realize they started there too.
They did. But their senior VP of sales is quoted in the report explaining that scaling highly mobile power units introduces a complete logistical nightmare because of the batteries.
Yeah. Heavy batteries degrade rapidly when they are constantly bouncing around in the back of a box truck. They're subjected to extreme temperature swings, and they're being discharged at really erratic intervals.
So the wear and tear is just brutal.
Exactly. The operational overhead was eating their margins alive. So FreeWire pivoted to a completely different workaround for the grid bottleneck.
Which brings us to their current product, the Boost Charger. But looking at the photos and the specs in the Trellis report, I really have to challenge the premise that this is a mobile solution at all.
It is pretty bulky.
The Boost Charger is the size of a phone booth, and it sits outside a gas station or a grocery store for months, sometimes years at a time.
Sure.
So how does a stationary phone booth fit into the mobile charging market? And more importantly, how does it solve the grid problem if it's just sitting there plugged in?
It solves it through what the industry calls a battery buffer concept.
Okay, break that down for me.
Sure. Imagine the traditional electrical grid at your local grocery store is a standard garden hose.
Okay, got it.
Now, if that grocery store wants to install a traditional DC fast charger, they need a massive surge of electricity. They basically need a fire hose.
Right, to push all that power that fast.
Exactly. But upgrading from a garden hose to a fire hose requires the grocery store to pay the utility company for incredibly expensive transformer upgrades, which takes months of permitting.
Nobody wants to deal with that.
Right. So the FreeWire unit skips the upgrade. It just plugs straight into the existing garden hose.
Wait, because the phone booth itself is a giant battery. It doesn't need the fire hose because it acts as its own water tower.
That is the absolute perfect way to visualize it.
Yes.
The unit uses its massive internal batteries to slowly sip power from that low-voltage grid connection over roughly 8 hours.
So it's filling its own reservoir quietly in the background.
Exactly. Then, when a driver pulls up and plugs in, the FreeWire unit just opens the floodgates. It dumps that stored energy into the car as a massive DC fast charge.
Taking a vehicle from 20% to 80%, incredibly fast.
Right. And once the car leaves, it just goes back to sipping. It can actually handle 15 to 20 of these high-speed charge sessions every single day.
Wow. But why is it called mobile?
It's categorized as mobile because you can literally drop it onto a site with a forklift, plug it into a standard commercial outlet, and instantly have fast charging. No tearing up the concrete, no laying new high-voltage lines.
And if you run a retail store or a local business, the financial case for this buffer system is just fascinating.
Oh, the economics are the best part.
Yeah, the Trellis article points out that these FreeWire units do cost about 30% more upfront than a standard charger.
Well, yeah, because you are paying for all those heavy internal lithium-ion cells.
Right. But by doing that, you completely avoid the massive utility demand charges.
And those demand charges are the hidden killer for small businesses. Utilities track your peak power usage, right?
Yeah.
If a standard fast charger suddenly pulls a massive spike of electricity from the grid for 20 minutes, the utility hits the business with a demand penalty that can wipe out their profit margin for the entire week.
That's brutal.
Yeah.
And the battery buffer smooths that spike out entirely, so the utility never even sees a surge.
Exactly.
On top of that, Trellis notes they save up to 70% in long-term operational costs. Plus, FreeWire integrated these really deep software analytics into the station itself.
Which retailers love.
Oh, for sure. The retail operator doesn't just provide power anymore. They get granular data on who is charging, what time of day they arrive, how long they stay.
It's a goldmine of data.
It allows, say, a grocery store to push a targeted coupon directly to the driver's phone for a coffee or a sandwich while they wait out their 20-minute charge.
They took a physical infrastructure bottleneck and somehow transformed it into a customer acquisition tool. It's brilliant.
It really is.
Yeah.
All right, so we've covered planned fleet charging with the SparkCharge vans, and we've covered the retail pop-ups with FreeWire.
Let's get to the stressful part.
Let's bring this down to the most stressful, completely unplanned scenario possible.
Being stranded.
Yes. You aren't at a grocery store, and you certainly aren't managing a state agency. You are driving down the interstate, the weather is freezing cold, and your battery just dies. You are stranded on the shoulder of the highway.
The classic roadside rescue scenario. This is where that internal AAA testing data provides an incredibly clear look at the reality of EV failures.
I have to say, I was initially pretty skeptical reading the introduction to the AAA report.
Really? Why?
Well, modern EVs have incredibly sophisticated routing software. The car literally maps out your route, tells you exactly where to stop, and calculates down to the minute how long you need to charge to reach the next station.
True, the guardrails are definitely there.
So with all those safety nets, are people really running out of juice that often?
It's a great question. And the data proves that our perception of the problem doesn't always match the reality.
Let's hear the numbers.
In 2022, AAA responded to 101,692 EV-related service calls.
Over 100,000. Okay.
But out of all those events, only 2.1% were actually out-of-charge scenarios.
Wait, really? 2.1%?
Yep. The vast majority of EV roadside assistance calls are actually for flat tires or a dead 12-volt battery.
Which are the exact same issues that plague traditional gas cars.
Exactly. The drivetrain is different, but the tires are the same.
2.1% is a fraction of a fraction. It's tiny.
It is statistically tiny. However, the psychological fear of running out, that deep-seated range anxiety we talked about, it remains a massive barrier to widespread EV adoption.
Even if it rarely happens.
Right. And AAA recognizes that to support the transition, they have to address the fear. They need to show they have a safety net, especially for first-time drivers.
Ah, like the rental market.
Exactly. The AAA report explicitly mentions Hertz, which recently added over 48,000 Tesla Model 3s and a whole fleet of Polestar 2s to their rental lineup.
Think about that rental dynamic for a second. If you're a business traveler renting an EV for the very first time at an airport, you don't know the car's real-world range.
You don't have the apps downloaded.
Right. You don't have accounts set up for the bullet charging networks, and you definitely don't know how the local climate is going to affect the battery.
You are the absolute prime candidate for severe range anxiety.
So AAA is basically using these rental scenarios as their testing ground to figure out how to rescue people efficiently.
Which leads to what I think is the most revealing part of the AAA documentation, the rigorous equipment evaluation they conducted.
The head-to-head test.
Right. They ran a comparison between the Blink mobile charging unit Generation 1 and the newer Generation 2 model. It is a literal masterclass in understanding the gritty, real-world operational trade-offs of roadside service.
Let's break down the Gen 1 specs because it is an absolute beast.
It really is.
It's essentially a massive commercial-grade charger permanently mated to a gasoline-powered generator. The Gen 1 output is 12 kilowatts of continuous power.
Which is pretty solid.
Yeah, in their testing, it provided an average of 19.25 miles of range in a 30-minute rescue window. That is more than enough to get a stranded driver to the next highway exit or public charging station.
Yet there's a catch.
A huge one. The downside is staggering. The Gen 1 unit weighs 365 pounds.
Right. Now compare that to the Gen 2. AAA tested the newer model, and the power output actually dropped significantly.
Down to what?
The Gen 2 only pushes 7.5 kilowatts. As a result, in that same 30-minute window on the side of the highway, it only yields 16 miles of range.
Down from 19.25.
Exactly. But the crucial metric for AAA isn't just the power, it's the weight. The Gen 2 unit dropped down to 230 pounds.
So wait, why would a roadside rescue company intentionally choose to downgrade their equipment and give a stranded driver less power?
You have to look at it from the perspective of the tow truck driver. Think about the daily reality of a roadside technician. A 365-pound generator takes up an enormous amount of physical space and payload capacity in the bed of a service truck. These units often have to be permanently mounted or bolted to the truck chassis to prevent theft and handle the vibration of the road.
Oh, I see. And if out-of-charge events only account for 2.1% of their calls.
Exactly.
You can't have a 365-pound behemoth taking up a quarter of your truck bed permanently just for 2% of your job.
Right. The driver needs that space for floor jacks, air compressors, and jump boxes for the other 98% of the calls they run every day.
That makes total sense. By dropping to the Gen 2, AAA sacrifices a tiny bit of speed, roughly 3 miles of range per half hour, to shave off 135 pounds of dead weight.
It's a very smart trade-off. It makes the gasoline-powered generator dramatically lighter, much more practical to maintain, and far easier to integrate into their existing fleet of trucks.
Without completely overhauling their vehicle payload limit. That physical compromise makes total sense. And clearly this logistical strategy is working out for them. The press release attached to the AAA data notes, they're expanding this free member pilot program significantly.
Yeah, the rollout is pretty aggressive.
They started testing in 11 cities and have now expanded to 24, rolling out trucks equipped with these generators to places like Columbus, Ohio, and Seattle, Washington.
It demonstrates a massive commitment to bridging that infrastructure gap. Even if a driver only utilizes the service 2% of the time, the peace of mind it provides is huge.
Especially to an anxious Hertz renter.
Right, or even just an everyday EV owner navigating a new route. It's an invaluable safety net for the entire industry.
So pulling all these threads together, we started by talking about the fixed reality of the corner gas station.
That century-old habit.
Exactly. But what emerges across all this data, the SparkCharge pilot, the free washer analysis, and the AAA testing, is an industry that absolutely refuses to wait for the traditional electrical grid to catch up.
The infrastructure is actively being decoupled from the earth.
It really is. You have SparkCharge putting fast-charging Lego blocks into the back of electric vans to hunt down rideshare fleets while they eat lunch.
And you have FreeWire using massive internal batteries to sip low-voltage power so they can drop a phone booth-sized fast charger outside a convenience store overnight.
Without a single permit for trenching.
Exactly.
And then you have AAA optimizing lightweight gas-powered generators to fit into the beds of their rescue trucks, ensuring that even if you miscalculate your route, the power will find you on the side of the highway.
The power grid is no longer a fixed destination. It is actively hunting you down to keep you moving.
Which leaves us with a pretty provocative thought to consider as we wrap up.
Yeah, think about this. If electricity can be buffered in a box outside your local grocery store, or summoned directly to your parked car via an app while you're sitting at your office desk,
will the traditional drive-in, fill-up, gas station model even survive the EV revolution?
Right. Or are we moving toward a world where we simply charge our vehicles in the background of our daily lives, rendering the dedicated trip to the fuel pump a complete relic of the past?
It really challenges how we think about our daily routines. The next time that little battery icon dips into the red, maybe you won't be scanning the horizon for a brightly lit sign at all.
You'll just pull out your phone.
Exactly. Maybe you'll just open an app, and the power will come finding you.